Dear students, welcome to the lecture series on the topic Engineering Graphics. Today we are going to discuss about isometric projections. I am Dr. IPS Ahuja, Professor, Department of Mechanical Engineering, Punjabi University, Patiala. Now today we are going to discuss about the construction of the isometric projections when the orthographic views of the solid they are available with us. Now here we have the front view and the left hand side view of a given solid. Now in this solid, since we have got the front view, so corresponding to the front view we can see that the length dimension happens to be 100 millimeter. The height of the solid, it happens to be 60 millimeter, and the width of the solid as it is available from the left hand side view, it is available as 60 millimeter. Now when we have to draw the isometric projections, we have to work out the dimensions of the three faces of the given solid, because in the isometric projections we are required to draw the front face, side face and the top face of the solid into a 3D pictorial drawing. So here we have got a 3D drawing into which all the three faces will be visible. So let us work out the sizes of the front face, top face and the side face. Now we can check from the given orthographic views that we have been provided with front view and the left hand side view. So this left hand side view has been drawn on the right side of the front view projections. Now since we have been provided with the left hand side view, so we have to draw the left side projections corresponding to the face, that is x-axis, and the y-axis over there, that is this xy plane, right? So this is the xy plane which is appearing on the left hand side. So this will be containing the information related to the left side view. So that is why we have to make sure that the face xy should be corresponding to the left hand side view. Now we see that what are the dimensions corresponding to the left hand side view. We know the width of the solid happens to be 60 millimeter. So we have marked 60 millimeter length along the x-axis over here, right? So this is the x-axis which happens to be 60 millimeter. Similarly, the y-axis, that is the height of the solid, so this is equal to 60 millimeter. So we have got this y direction, that is the edge of the solid will be 60 millimeter. And once we draw couple of isometric lines which will be parallel to the y-axis and the x-axis, so these two isometric lines, they are going to complete the square which we are going to obtain corresponding to the left hand side view. Now if this portion of the isometric projections is going to present us with the left side view, so obviously the front view has to be projected towards the z-axis over there, that is onto the z-axis. So the front view will be contained between y and z-axis of the isometric projection. So y-axis we already know this is equal to 60 millimeter height. Now let us work out the z-axis dimension. So since the length of the solid in the front view is available to us as 100 millimeter, so this 100 millimeter length will be plotted along the z-axis. Now we are going to get the front face equal to 100 millimeter by 60 millimeter, where 60 millimeter is the height of the front face and 100 millimeter happens to be the length of the front face. So once again, if we draw two isometric lines over here parallel to z-axis and the y-axis, okay, so this edge we are going to draw parallel to z-axis and this edge will be drawn parallel to the y-axis. So we are going to get the completion of the front face of this particular solid. So in the top face, if we construct an isometric edge over here which will be parallel to the z-axis, and we construct another isometric line which will be parallel to the x-axis over here. So in the xz plane we are going to get the bottom face of the solid, and similarly the top face will be constructed through this height of the solid over there, which is equal to 60 millimeter. So the bottom face and the top face will be identical, and this will give us the dimensions as of the top face. Now once we have known that the front face dimensions, they are equal to 100 millimeter by 60 millimeter, and they will be drawn along the YZ plane. Similarly, the side face, it will be 60 by 60, it will be drawn along the XY face, and finally the top view will be 100 millimeter by 60 millimeter, and it will be drawn between XZ planes over there. Now we have to start with the construction of the isometric projections of this solid. Now in order to draw the isometric projections of the solid, now we need to convert all the dimensions which are available to us through these two orthographic views from true length to the isometric length over there. That is, all the true dimensions, they will be converted into the isometric dimensions, and only then we are going to start with the construction of the isometric projections of the solid. And as usual, so we are going to start with dividing this complete solid into multiple small elements over there, so that the construction of the isometric projections can be simplified. So please check, here we have the bottommost portion of this particular solid. So we can check, this is a solid line. This solid line is appearing, that is, this section is appearing corresponding to this surface over here, right? So this is the surface, and then there is the bottom portion of this particular solid, which happens to be flatter one. So this bottom portion, this is our element number 1. Okay, so this is the bottommost portion of our solid. We are going to refer to this particular portion as element 1 over there. Then the second element is, you can check that this particular solid is going to have two vertical webs over here. So this is one vertical web and this is another vertical web. Now even though from the side view it appears to us as a vertical web, but when we look at these two webs in the front view, we find that these are the sloping webs that we have got. Okay, so this is our element number 2 over there. That is, there are two webs over there which are of the slanting nature, but if you look at them through the side view, they may appear to be a vertical web. So these are basically two webs over there. In the side view, they will appear to you as the vertical webs, but in the front view you will find that they are the projections of the slanting web over there, which is originating from a point 20 millimeter in front of the rear edge. So this is the rear vertical edge of this particular solid, right? So this is the rear vertical edge. So starting from 20 millimeter, so that is the top 20 millimeter portion of this particular web will be straight, and then this will be sloping down from this point onto a point on the lowermost ring at a distance of 20 millimeter from the left vertical edge over here. This is my left vertical edge of this solid, and as we move along 25 millimeter, so this is going to be the second point of the web. So the starting point of the web will be starting from 20 millimeter from the rear surface. Okay, so this surface will be flat. And third thing is there into this element, that is, as you are going to have these webs which are running through this much portion of the solid, that is, this is 20 millimeter, this is 25, so total is 45. So this particular web will be running through 55 millimeter horizontal length of this particular solid. So this is the remaining 55 millimeter length through which this particular slant web will be running through. And third thing is that as this web is running down, but in between, as you see, this distance is given to us as 15 millimeter. So the bottom portion of the solid of the element 1 is having the thickness 15 millimeter, and you get 30 millimeter from the top. there is a flat portion in between the two webs. So there is a flat portion over there. Okay, so it's not that the webs they are running through and through up to this point. So they are running up to this point, and then this portion will be solid. Okay, so this portion of the element number 2 has been filled out. So you are going to get hollow portion over here in between the two webs. So in between the two webs there is a U shape of the hollow portion. So this is our element number 3. Element number 3 means there is a U shape of the hollow portion, or otherwise we can say that if this distance is 15, so this distance from the top of the element number 1, from the top of the element number 1, so this surface of the hollow portion of element number 3 will be 15 millimeter above this top face of the element 1. So this is the description that how we are going to divide this particular solid into multiple elements, and now we will see how all these elements can be combined and they will give us to draw the isometric projections of this particular solid. So this way, by combining these elements, we are going to work out the procedure which will facilitate us working out the isometric projection. So step number 1, here we have the horizontal line. So this is our horizontal line or a ground line. We call it a datum line. At the datum line we have a starting point. So from the starting point we move towards left at an angle of 30 degree. So this is an isometric x-axis that we have drawn. Similarly, we are moving along the right direction at an angle of 30 degree. So this gives us a construction of the z-axis, that is the isometric z-axis. So along this particular side, that is along the x-axis, we have already discussed, because the left side view has to be located along the x-axis and the y-axis. So we are going to mark the width of the solid over here. Similarly, the length of the portion, that is the front view, will be located over here between y and z dimensions. So the length of the solid will be drawn over here, and finally the height of the solid will be drawn along the y-axis. So let us draw the width of the solid. So please check, the width of the solid is equal to 60 millimeter. So this width happens to be 60 millimeter, and the height of the solid also happens to be 60 millimeter. So this width is also 60, this height it is also 60, right? So you get width is equal to height is equal to 60. So this is the construction of the square side face, right? So this is the construction of the square side face. So this is our square side face, 60 by 60. So this is along the y-axis 60 millimeter we have marked, along the x-axis 60 millimeter we have marked, and then these two isometric edges they have been drawn to complete the construction of the square face corresponding to the left side view of this particular solid. Now, having drawn the left side view, now we need to mark the front side view rectangle over here, because the front face will be inscribed within a rectangle having size 100 millimeter by 60 millimeter, where 100 millimeter happens to be the length of the solid and 60 millimeter happens to be height of the solid. So the height of the solid we have already marked in the side view. Now we have marked the length of the solid, and now we are going to draw once again two isometric edges which will be parallel to z-axis. So this edge, it happens to be parallel to z-axis and equal to 100 millimeter. Similarly, the second isometric edge, it happens to be parallel to the y-axis and it measures 60 millimeter. So this gives us the rectangular face where the front view projections will be available over here. Then we have to draw the top face. So the top face, we know the side, that is the size of the top face will be 100 millimeter by 60 millimeter. So 100 millimeter edge we have drawn parallel to the z-axis, and 60 millimeter edge we have drawn parallel to the x-axis which was showing the width. So the top view shows the length and the width of the solid, right? So side view shows the width and the height, whereas the front view shows the length and the height of the solid. And let us complete the base of the solid as well. So corresponding to the base, we have got two isometric edges. So first isometric edge will be 100 millimeter long. It will be parallel to z-axis, and the second isometric edge will be 60 millimeter. It will be parallel to the x-axis. And you can see, because it is a square prism that we have drawn, so we have got the overlapping of this edge, that is the top edge over here, outermost one, and this edge of the base over there, right? So this becomes a perfect square. Only then these two edges, they are going to overlap with each other. And then from this corner, we have to draw the vertical edge corresponding to the back face of this particular solid over there. So this is the front face, right? And this one is the back face of the solid. And again, this edge height will be 60 millimeter, and this will be parallel to the y-axis over there. Now let us start with the lowermost element, that is the element which lies at the bottom. So the element which lies at the bottom, what are the dimensions? So the dimensions, they are height is equal to 15 millimeter. Then you have the length of this element 100, and the width of this element is 60. So we are going to draw a ring over here. So complete rectangular ring we are going to draw at a height of 15 millimeter, which is going to provide us the guidance for drawing, or the reference for drawing the element number 1 or the base element over there. So here within these, you see, reference line, we are going to draw the base element. Now we have drawn the ring corresponding to element number 1. Now we have to start with element number 2. So element number 2, once we start with, you see, two things will be required. The first thing is, element number 2 starting point is 20 millimeter from the rear end. So this will be our flat surface. So this will be the starting point of this inclined surface. Second, the inclined surface is going to end 25 millimeter from this particular front face over there. This is the rear face and this is the front face. So it is going to end at a height of 15 millimeter and at a distance of 25 millimeter from the front face. So please check, this is my front face, and 25 millimeter from the front face I have drawn a point over here. So this will be one point. Similarly, this will be another point. And then from these 2 points, I am going to draw a U over here like this, so that the ground point can be located, which will be at a distance of 25 millimeter, and the vertical edges, they will define the location of the ground edge over here. So this is the ground edge. So from 25 millimeter, we have drawn an isometric line which will be parallel to y-axis and which will be parallel to this edge of the solid. Please see. And then another vertical edge we need to draw, which will be parallel to this edge of the solid, right? So both the vertical front edges are there. So 25 millimeter from the either edge, we need to draw these vertical projection. And then we are going to join both of these, so that, because ultimately this has to end onto the ground. So from here we have to move to the ground point. So this ground point on either side of the face, it has been located, right? So the distance where this will be meeting the ground, it is 25 millimeter from the front face. So this is our front face. So 25 millimeter from the front face at the ground. So I am interested in this point. I am also interested in this point, right? So this is what I require. Then, so these webs, they are going to start, please check, 20 millimeter in front of the rear face, first thing. Second, the thickness of these webs, it is equal to 15 millimeter. It is available to me through the side view. So this web will be starting from a point 20 millimeter in front of the rear face. This is my rear face of the solid, and it will be extending 15 millimeter towards the other end. Similarly, the width of this web will be 15 millimeter. So from this corner, it will be moving towards this side 15 millimeter. From this corner, the web top portion will be moving 15 millimeter towards this side. So on the top, once again, we are going to get a formation of a rectangle, the rectangle size will be 20 millimeter over here and 15 millimeter over here, so that the flat portion of this particular web can be obtained. So let us do it. So please check. This web is going to start at a distance of 20 millimeter in front of the rear face. So over here also it will be the same distance, and the thickness of the web we also know, 15 millimeter from this side and 15 millimeter from this side. So this is first thickness, this is my second thickness of the web. Now I have obtained the dimensions of the web flat surface. So let me draw the flat surface. Please check. This is my flat surface. So this is an isometric line which is parallel to this isometric line. Similarly, this is my isometric line which happens to be parallel to this isometric edge over here. Similarly, over here, flat surface has been drawn. This edge of the internal portion of the web, it is drawn parallel to the isometric edge over here, and similarly this edge of the web corresponding to the flat surface of the web, it has been drawn parallel to the rear edge of this solid. So the top face, please check, having dimensions 20 millimeter by 15 millimeter has been obtained over here. Now I know that from this point, that is from this corner, my web, which is a slant web, it is going to start from this point. It will be ending up at a point at a distance of 15 millimeter above the base, or at the top of the ring, we can say, at a distance of 25 millimeter from this particular front face. So from this particular front face, this is the 25 millimeter at the base. So now I am going to join this point with this base point over here. Similarly, this point of the corner will be joined with this point of the base. Okay, so this way the slant edges will be obtained corresponding to the web. So this is the slant web. So it starts from this point, it will be ending up at this particular corner over there. Similarly, this is the slant web which will be starting from this position and it will be ending up at this particular corner. So the outer portion of the web has been drawn. So this is a continuous portion. So this has been drawn starting from this point. It will end up over here. Outer portion will start from this point and it will be ending up at this portion. But what regarding the internal portion of the web? So internal portion of the web doesn't meet at this particular position, such that the hollow portion is not this big. Rather, this is a solid portion that we are having. So what to do? This distance is equal to 15 millimeter. So two things we can do, that either we can draw a distance of 30 millimeter from here down, because this distance happens to be 30 millimeter. So either I can draw this distance 30 millimeter, or from this ring I can take a 15 millimeter upward distance. So this line, that is this face of the hollow portion, it will be 30 millimeter from the bottom and it is 30 millimeter from the top. Now I have obtained the bottom line, that is 15 millimeter above the base over there. Now I need to mark this particular web, right? In order to mark this particular web, please see what I have done. I have drawn this flat portion. Please check. I have drawn this flat portion 15 millimeter above this reference line which I had drawn to represent the bottom of the web over here. So this was the bottom of the web. So from this point I have drawn this edge, again a reference line, 15 millimeter above this particular top face of the rim, so that this thickness, please check, this thickness I have mentioned as 15 millimeter. So this is 15, this is also 15, so automatically this is 30 over here. So this is 15, this is 30, so automatically this is 15, right? So this way, this distance I have marked as 15 millimeter. Or the second method could be, please check, I drop a perpendicular from this corner which should be equal to 30 millimeter. Please check, I am going to drop a perpendicular projection which will be equal to 30 millimeter, which will be defining this wall, right, which will be defining this particular wall corresponding to this hollow portion. And then once I drop a perpendicular 30 millimeter, Then parallel to the z-axis, please check, parallel to the z-axis, I will be moving again parallel to the z-axis over here, and I will be getting a point of intersection over here. So this way I can work out the length of the internal corner, internal, you see, edge of this particular web. So I could have drawn this horizontal line up to this. So once I draw this perpendicular parallel to the y-axis, then I draw this isometric line parallel to the z-axis. So wherever this construction it intersects with the internal edge of this particular web, I am going to get this joining point. Or the second method is you draw 15 millimeter height. Please see, now I am going to show the dimensions. From this top surface of the ring, draw a distance of 15 millimeter upwards, so that the thickness of this web in the side view, this happens to be 15 millimeter. This inclined surface will be having the larger length, but the vertical length I am bothered about. So the vertical length from this ring point should be 15 millimeter over here. So this way I need to evaluate the starting point of this U, and similarly this point will also be obtained. So by two methods I can obtain this point. First method is you draw a distance of 15 millimeter, because this distance happens to be 15 millimeter. So the vertical distance is 15. So the inclined distance will be slightly more than 15. So this vertical distance I have marked as 15, and wherever it intersects the inner walls of this web, I will be getting these two intersection points. First. Second method, I will be drawing a vertical edge equal to 30 millimeter parallel to the y-axis, and then draw a isometric line which will be parallel to the z-axis. So wherever this construction meets this inclined portion or on the inner side of the wave, this point of intersection, or this point and this point, these 2 points, they will be located. So by two methods we can locate it. Now you can check the distance between these two webs will be 30 millimeter, and similarly I have shown it over here, right? So I will be deleting this particular dimension later on, but only just to show you that this distance happens to be 30 millimeter, we have drawn these orange dimensions. So whatever dimensions are drawn with orange, so it means we can eliminate these dimensions later on. These are only for your guidance or your reference. So all dimensions with blue and black, so they are the ones which must be shown otherwise. So please check, I have shown this dimension 30 millimeter, that is I am following this distance as well. So this is 30, this is 15, and bottom is also 15. So 15 plus 15 plus 30, this will give us the vertical edge equal to 60 millimeter. Now the horizontal edge will be, once again, this will be parallel to the x-axis. So this remaining portion has been covered by this slanting web. So that's why even though this distance was 30, this is also 30, but some portion of this 30 has been covered by this slant web. So that is why the remaining portion has not been shown over here. Now this completes the construction of a solid which is having a base element, and the second, it is having two slanting webs, and it is having a hollow portion in between. You can check, this is the hollow portion in between which has been shown over here. This is the hollow portion. So this has been drawn. The two webs, the top portion of the web, it was flat. So this has been drawn. The remaining portion of the web, this was hollow. So this has also been drawn. The front portion of the web has been shown over there. You can check. This is the total web which we have drawn. And then this is the base element which has been completed. Now we will start darkening the different elements which are visible, right? So which are giving us this shape of the object over there. So this top surface was a rectangle. It has been shown 20 by 15 and 20 by 15. So top portion of the webs, they were flat. They have been identified over here and located over here. Then you have the inclined webs. So this is the inclined web. Internal portion of the web is hollow. So there is 15 millimeter flat over here. there is 15 millimeter inclined surface over here, and there is 30 millimeter this hollow portion over here. So all these portions, they have been identified and appropriately located. So this is my flat web and this is my U shape of the web. And let us show the front portion. So this is the front portion corresponding to this one, 25 by 60, and height is equal to 15. So height is 15, this width or the length is 25, and this depth over here is 60. So this is 25, this is 15, and this is 60, right? So this is the flat portion of element number 1, right? So element number 1 has been drawn, and you can check there is no straight line over here. So since there is no straight line, it means this portion of the solid, it is connected to each other. So element 1 and element 2 from this front view, they are connected with each other. So this line will not be drawn dark. Rather, we have to draw this edge dark over here, and this edge should be drawn dark, so that we get a complete portion over here as a single unit, right? So this portion will be shown as a single unit, okay, just like this way. And then corresponding to this surface over here, the dotted line will be there in the front view. So let us darken this portion also corresponding to this hollow portion. So this is our hollow portion. Let us join the lines corresponding to the hollow portion. So this is one edge, this is my second edge which needs to be joined, and this is my third edge. So there are three edges in this construction, in this isometric construction, which have to be joined in order to show or represent this hollow portion. So this element number 3 has also been completed over here. So element 1, element 2, and the hollow portion is our element 3. So corresponding to element 3, we had the dimensions 15, 30, and this 30, right? So these were the dimensions which were representing element number 3, that is the hollow portion. So with this, we have been able to complete all the construction. Now you can check, since this dimension was not required, rather it was repeated twice. It was only for illustration that this has been drawn. So I have removed this. Even this can be removed. Why? Because I have been given total dimension. Please check, this is equal to 60 millimeter. Total width of the solid is given to me as 60, and the width of the web was given to me as 15, and this is also given to me as 15. So I don't need this dimension either. So this also I have removed now. So this is the complete construction of the isometric projections once the orthographic views they were available, and we have been able to construct this isometric projection by dividing this complete object into smaller elements, and one by one we have been able to locate all of these elements into the isometric projections, and then by combining those elements we have been able to develop the isometric projections of the solid corresponding to the orthographic views. So this is all for today. So I hope that with this discussion it would have clarified to you that how you can proceed to draw the isometric projections from the orthographic view projections which are available. Thank you very much. Thanks a lot.